Great. Okay, now I think it's working. Okay, sorry about that. Now that we have this working, let's go ahead and read the puzzle description. Great. Please feel free to yell in chat if I have broken it again. But okay. So we need to run a diagnostic program with our int code computer. Great. So opcode 3 takes a single integer as an input and saves it to address given by the parameter. The instruction 350 takes the input value, great, and stores it at a given address. So out before outputs the value of its only parameter. Wait, does 350 take the input value 50? Or like what's going on there? That's a little confusing. Okay. Program outputs whatever it gets as input. Oh, input as in on the standard, like as in standard in. Okay. Input instruction, provide one ID for the ship's air conditioner unit. Okay, got it. I think I understand what I'm supposed to do here. Let's go ahead and implement. So let's go ahead and head to my directory. And let us copy this. Okay. That all seems fine. And basically what we're going to need is we're going to need to edit my VM to give it a... So how many inputs can I potentially get here? Input and output diagnostic code and halt. Okay. It's the only input instruction. So at the moment, I only have one input instruction. This is tolerable. So let's go ahead and let's do this. Okay. And I probably will have to configure this as well later. Okay. Great. So if I get the input 3, or if I get the opcode 3, then I need to store the input value in that address. Okay. That has only 2 operands. So let's see, that just takes A. I think that should do the trick. All right, and then finally, opcode 4 outputs the value of that. So what does output do? Okay. So I need to print this. Okay. I think something like that should do the trick. So now let's see this. Let's also go back and read the special instructions. Special instructions say, we also need an option to add parameter modes. Parameter mode 0 interprets the parameter as a position. We also can get immediates. Oh, that's interesting. Parameter modes are stored in the same value as instructions opcode. The opcode is a two-digit number based off of the ones and tens. So I can just use %100. Okay. Parameter modes are any missing modes are 0. Okay. Got it. Great. That is totally reasonable. So let's go ahead and flip back over here and handle that. Okay. So okay. So that's like that, but I need the various parameter modes as well. Oops. Great. Okay. So let's see. We have over here our set of instructions. So I need to, okay, the third one is in the tens, thousands digit. Okay, got it. So great. Okay. Fine. So if p modes equals, let's see, so if it's 1, then it's use register mode. Else, okay, so we need to deal with this slightly differently. Going to need to handle this slightly differently. So we need to do some refactoring, and that's fine. So okay, so instructions 1, 2 are 4, and then 3, 4 are. Okay. And 99 immediately returns. That's fine. Great. So now I don't need op length. Okay. Okay. That's fine now. Okay, that seems okay. Shall I do this? That seems okay. Hey, Becca. All right, now inst.len of instruction. Okay. With a length of, okay. Okay, that seems fine. Oh. But this could be assignable as an output, which makes this a little bit more painful. Parameters and instruction writes to will never be in immediate mode. Okay, that's fine. Okay. For now, we'll handle it this way. It's fine. And this is, the tape is a index of ints. So if I pass an index, I think it will update it correctly. Maybe? I'm not sure how this behaves in Go, actually. I'm not 100% sure, but we'll work it out. Okay. All right. So operands of I is going to be of offset plus I. Yep, okay. Great. Otherwise, we wind up using it as a literal. And in that case, it's going to be, instead of reading the tape, we're just reading the literal value that is found in the instruction. So that's going to be let's see. Wait. What was I doing before? Okay, t at offset. What was this before? So this was at... Oh. Wait, now I'm very confused. So let's go back and read the instructions, because I am clearly twisting myself into knots here. In position mode, please do not get me copyright struck. Thank you.
Yep.
3 in immediate mode simply has the value 3, which is the thing in that parameter at that location. Yeah, okay. Oh. Yeah. Okay. So if it's in... Okay. Okay. Paren 0. Yep. Okay. Got it. That is... Now I understand what I was doing wrong. Okay. So I think this couldn't be more concisely and clearly expressed this way. I think that will do it. Okay. Now I feel okay with this. So this is called position mode. And this is called literal mode. Okay. And then finally, we need to continue shifting this. Okay. That seems fine now. And then finally, oh, I actually don't need operands mode because I know the, yeah, okay. Yeah, okay. I know that it's always going to be in the correct mode for the output. Yep, I believe it. So I don't need outputs. Great. So it will always be in position mode to write an output. Parameters that an instruction writes to will never be in immediate mode, which means that it'll always be in position mode, but it means that I'll have already read that value, which means I'm not going to have access to the operand. Okay. Oh. But this is effectively a solvable problem because okay. Yeah, I think something like that will do. I just don't like this because it's really, really ugly. Okay, I see how to do this. T of offset plus instlen minus 1. Okay. Okay. Actually, wait, that's just the same as calling it this. Great. Cool. Okay. Great. Okay. Can I be asked to literally output an immediate? Yeah, the parameter is interpreted as a value. Yeah, outputs the output of the, yep, okay. Okay, that's correct. Great. Cool. I'm pretty happy with that code, except for it doesn't compile because something on line 59. All right. Hey, Xanhex. Oh, I'm silly. There we go. What happened to my P modes? Where did I put? Okay. I think that should do the trick. Cool. Let's just make sure this still works. No, it does not. Instlen. Oh. Okay. Oh. Okay. Out of index at line 59. All right. Oh. Right. Right. Why don't we do this way? It'll be simpler that way. Yeah, I feel like this is the smarter way to go because it indexes by the start of the instruction, which feels slightly better. Okay. Oh, there we go. What have I done wrong? Offset plus I, that seems fine. That seems okay. Oh. Oh, I see. Yep. Yep. Okay. All good now. Let's see. Does that match what I got before? Let's find out. On my day 2, I should have gotten... Yep, that's fine. Let's do part B real fast. 7870, yep, that's fine. Good. Okay, great. I have not broken my int code computer. Back to solving the day 3 problem. Or day 5 problem. We're on day 5, I swear. I swear I know what I'm doing. Okay. Position immediate mode, yep, okay, that's fine. Yep. Okay, so all 0 except for the diagnostic code at the end should be what we expect to see. So let's paste this in and see what happens. Okay, so I have this. Day 5. Index out of range 1100. That 1100 is here. Okay, so this is incorrect advancing because this is a opcode here. This is an opcode, not a value. Let's see. So I'm executing instruction 3 to pull the input. Then I'm into position 225, executing instruction 1 to multiply those two things together and store there. So 1100 should be a real instruction, but yet it's being treated in line 59. In line 59, oh, that should not have had 1 added to it, that's why. Okay, failed to match opcode 0, which makes sense because 1100 should not have been a valid opcode. So what is the opcode supposed to be? 2-digit opcode. Rightmost digits indicate opcode 2. So 1100 should be, from my reading, opcode 0. Should it not? I feel like the answer is yes, it should be opcode 0. Okay. 2 new instructions, opcodes 3 and 4. Yeah. Writing 1 to the only input instruction. Oh. Supposed to... That doesn't matter. Wait. What's going on here? Oh. Lol. That's funny. Okay. Oh, I'm just overwriting all of this shit because yeah, okay. Not good. Not good. Day 5.go needs to literally run the tape. Okay. That seems reasonable. And my input value My input value needs to be fed input value of 1. Okay. Kick-ass. That will get me for being sloppy. Okay, that works much better. Why am I getting that extraneous print, though, at the end? Oh, because I print line the... Oh, because it's giving me the value in register 0. Okay, good. So I believe that this is correct. And Eric's code agrees. Great. Continue to part 2. So, here she comes online. We need to extend the thermal radiators. Yep. Okay. Great. Let's do this. Cool. So we have a instruction with length 3. We have an instruction with length 3 again. We have a instruction of length 4. Okay, great. I need to start commenting these. Okay. Okay. 5, 6, 7, 8. Easy enough. So this is jump false, less than, and greater than, and now we are actually finally Turing complete. So, jump is true. If the first parameter is non-zero, it sets the instruction pointer to the value from the, okay. It sets the instruction pointer increments by the number of values in the instruction. However, if the instruction pointer was modified, then the instruction pointer is not automatically increased. You're right. Okay. 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 Wait. If the instruction modifies the instruction pointer, that value is used. That seems like an unclarity, because what happens if you set it to the exact value that it is at right now? Okay, so we're going to do it this way. Okay. Great. Let's just do it this way. This is my most straightforward reading, and if it winds up being weird, then we'll do it. Okay. If operand's 1, and that is just if it's non-zero, then offset is going to be it's 2. Non-zero. Okay. For false, yep, that's fine. Less than and greater than are just storing 1 and 0. Okay. 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 Greater than. All right. Okay. All right, that should do it. Let's go ahead and find out how I trigger this code to run. Okay, give it 5. Okay. All right. Wait, that only outputs 1 value. It doesn't output any zeros, but maybe that's fine. Okay, let's try that and see if it works. Nope, not the right answer. Okay. Penalty box for 1 minute, and I will go back to trying to debug this. Okay, let's give it a simple input, which is this one. And see how that does. This should output 989 if it's below 8. 1,000 if it's equal to 8, and 1001 if it's greater than 8. So those are clearly wrong. Okay, that means that I know what I'm doing wrong. This also means that there is no part B here. I do still need the debug flag. That's fine. Okay. All right. So let's see. What did I do wrong here? If it's less than given by the third parameter, or is it 0? Oh, it's equals, not less, not less. Ah, there we go. Oh, now I feel like a moron. Okay. That makes total sense. Okay, so now this should actually work. 5, 8, 10. Okay. So it's just a matter of me failing to read the puzzle. There we go. That is still not correct. Oh, because I fed it the wrong input. Ugh. This is what I get for sloppy copy pasta. Now I need to wait for a minute, but I'm pretty sure this is correct now. "25 seconds. Okay. It's one of the cases where rushing causes you to take longer to solve it rather than less time to solve it. In the meanwhile, let's go ahead and clean up some of my code. The penalty does escalate the more you guess wrong, but yeah, something like a minute or 2 minutes delay is normal. So 3 seconds. By the time this loads, it'll have gone correctly. There we go. Rank 516, not bad. Okay, great. Let's go ahead and clean up my code. So what are the cleanups that I want to do today? The cleanups I want to do are primarily around... Oh, I see. Yeah, I think what I would like to do is I would like the instruction table to wind up being in the same place as a lambda that takes the operands and the offset and so forth. But maybe I will not do it today, having had my stream marred by technical issues at the start of the stream. I'm happy enough with this, so I'm probably going to call it a day. Let's just look over this and make sure that this is fine. Yep, that's fine. Oh, I don't need to copy the working tape anymore. This is just that. Okay. And I don't need to output the value in position 0 for this problem either, so we're just going to run tape process and call it a day. Yeah, I think that, and also let's make this run with the correct arguments, maybe? No, that's fine. Just make sure this still works. It does. Wonderful. Okay. Add day 05 solution. Excellent. Cool. Well, thanks for watching, folks. See you tomorrow. Probably a little bit later than the puzzle release time, unfortunately, because I have to go and attend a meeting with a Honeycomb customer. So I will see folks later. Why don't I use Go's testing utilities to compare the programming examples? I don't actually know. Probably I just tend to use examples only when I'm doing heavy diagnostics. If I'm relatively confident, then I'll just run it once or twice and be done. Excellent. Well, take care. See you folks.